back, everyone. So I'm very pleased to start the final part of the day with Farina Farrier from the Energy Networks Association, who will be introducing their work and the Open Networks project.
Okay, thank you. Hi everyone, I'm Farina from Energy Networks Association. I will be talking to you today about the Open Networks project. Can you all hear me? Yeah, okay. So the Open Networks project is basically an industry-wide initiative that's being led by the Energy Networks Association on behalf of the networks. And as part of this project, we are basically laying the foundations of a smart grid in the UK. So in terms of my talk today, here's just a high-level outline of some of the things I'll be covering with you. I'll be giving a brief introduction on Energy Networks Association, and then I'll move on to talk about the project and some of our key outputs. We'll have Q&A in the end. Just before I get into the main content, just a bit of a warning, there are a lot of acronyms, as we do have in the industry, so if you're not familiar with any of the acronyms, please feel free to just raise your hand and ask me. So the Energy Networks Association, we're basically the trade association that represents electricity and gas networks in the UK and in Ireland. And as the trade association, we are basically responsible for representing interests of the networks in the UK and in Ireland, and we basically provide a forum for collaboration and discussion on some of the key industry issues. Open Networks is one of the collaborative projects that we are leading on behalf of the networks. So just before we talk about the actual project itself, I think it's important to just provide a little bit of context about our energy landscape. So as you all know, we are going through an energy revolution, and we are seeing unprecedented change. And basically the change is being driven by what is commonly referred to as the 3 Ds, which are decarbonization, digitalization, and decentralization. So traditionally the electricity networks have operated as one-way power systems with large and more central generation located at higher voltage levels. But as we are starting to see more decentralization, we are getting smaller and more intermittent sources of energy connected lower voltage levels of the network. So basically there is a need for the networks to change the way they operate. So we need to operate in a more smart and flexible way. So this is what we call the transition to a smart flexible energy system, and often this is also referred to as the transition to a distribution system operator, the DSO. So basically in light of this context, the Open Networks project was set up 2 years ago with a view to basically address all the challenges that we are facing as an industry. So Open Networks project is looking at the changes that are required in the way the networks are operating to make sure that we can operate in a smart and flexible way. So we recognize that this is a very large change for the industry, and we need to make sure that in this journey we are taking stakeholders, customers, the government, and the regulator forward with us as part of this. So we are actively engaging with them to make sure that we are delivering a solution that meets everybody's needs. So just in terms of the timeline for the project, so basically we started the project in January 2017, and we basically started in our definition phase. So we started work by outlining what a DSO actually is, and we identified some principles for improvement that we can take forward in further phases of the project. So last year we then basically undertook an options development. So as part of this, we basically identified options for how we can actually transition to this smart flexible energy system in the future. And this year we are basically assessing those options and trying to understand what the implications for each of those options would be. And as I mentioned before, we see the Open Networks project as a long-term piece, so there will be future phases, and we will continue to support the transition to DSO, undertake any actions that are required to progress us in that journey, and will support regulatory enactment as part of this. So in terms of our scope and objectives, so broadly, we basically are delivering work in 6 key areas. So to progress each of these areas, we have formed a separate work stream, and what we've got here on the screen are basically 6 of these areas. So the DSO transition work stream is basically looking at the changes that are needed for distribution network operators of today to become distribution system operators of the future. So this work stream has a longer term and more strategic focus, but at the same time we recognize that we also need to look at what are some of the benefits we can deliver in the here and now. So in that dotted box we've got 4 additional work streams that are looking at how we can improve processes today. So the first work stream in this is flexibility services. So we are starting to so the electricity networks are starting to procure more and more flexibility services, and as part of this, there is a need for us to have some degree of standardization or commonality in how we approach these. So this work stream specifically looks at that and looks at how we can bring more convergence in how the networks are procuring flexibility. So the next work stream, which is our whole electricity system planning, transmission and distribution data exchange work stream, which is quite a long name for a work stream, but essentially what we are doing in this work stream is we're taking a whole system approach and we are looking at transmission and distribution, and we're looking at how we can basically optimize processes to bring some of them together and identify any synergies that can deliver more improved cost-effective processes. So the next work stream is our customer information provision and connections work stream. So we recognize that as part of this transition, customers need to be at the heart of this change. So this work stream basically looks at how we can improve processes for our customers. So they've particularly been focusing on the connection space and identifying areas that we can improve for customers. And this work stream also looks at how we can improve information provision for customers. So the fourth work stream that we've got is our whole energy systems work stream. So this is a new work stream that we've introduced this year based on feedback that we've got from our stakeholders. So this work stream basically takes a step beyond what we've traditionally been looking at. So rather than just looking at transmission and distribution in the electricity sector, it kind of looks at across other vectors as well. So we've only just introduced this work stream, so they are basically undertaking a bit of a scoping exercise to identify areas where there might be synergies with gas or with heat. Towards the middle of the year, we expect to have some defined outputs that will come out of this work stream. So the final work stream that we have is our comms and stakeholder engagement work stream. So we recognize that this project it's a large change project, and we need to make sure we bring our stakeholders with us along in this journey. So this work stream is responsible for making sure we're giving opportunity to the stakeholders to participate in this project and help shape our direction of travel. So in the next few slides, I'll be talking to you about some of the key areas of work that we've delivered under this project. So I'll start by talking about the DSO transition work stream and the work that we've delivered as part of that. So early in 2017, we started our work by defining what a DSO is. So essentially, I'm not going to read the definition word for word, but there are 3 things to highlight here. So distribution system operator is basically actively managing the network. So I think active is the key word here. So traditionally, they've basically played a more passive role, and a DSO requires more active management of the system. So the second element is neutral facilitator. So a DSO is a neutral facilitator of open and accessible markets. And then the third element is enabling customer access and providing as much choice as possible for the consumers to deliver good service for them. So alongside the definition, we also looked at what are some of the core capabilities that a DSO would require in the future. So we outlined 8 different functions here, and as you can see, some of these functions are basically existing capabilities that DNOs already have. So for example, network operation, this is something that the networks do on a day-to-day basis, but there are other functions that would basically require new capabilities to be developed. So market facilitation is an example of that. So future worlds, so I'm not sure if any of you have come across the term future worlds in the industry, but this is basically our largest area of work. So we've basically developed this work through substantial stakeholder engagement, and essentially what these are 5 potential industry architectures that are all capable of delivering the transition to a smart, flexible energy system, but essentially in different ways. So these models basically are ways in which DER services can be provided for meeting the network needs. So we've got the 5 worlds on the right-hand side here. So these are quite detailed, but just I'll have a go at summarizing them quickly for you. So world A is, we basically said world A is a world where the DSO coordinates. So in this particular world, the DSO is responsible for the procurement and dispatch of all services from DER. So what that means is the electricity system operator would tell the DSO what its requirements are, and then the DSO would be responsible for getting those flexibility services for them. So I'll now jump on to world D. So world D is basically the opposite of this world. In this world, the ESO is responsible for the procurement and coordination of all services, and the DSO would share their requirements, and then the ESO would essentially provide the flexibility services. So world B is basically a coordinated world. So we also call it the joint procurement world. So in this world, the ESO and the DSO can both procure services for their own needs directly, but there is a requirement for coordination between the DSO and the ESO to make sure that the services are used in the most efficient way possible. So world C is basically the same as world B, but basically in world C, the DSO and ESO can both procure their own flexibility services from DER, but in this world there's an added layer of forward-looking price signals for customers, so there might be or some organic flexibility in the networks as a result of this. And the final world, which is world E, is kind of different to all of the worlds that we have here. So in this world, there's an entity called the flexibility coordinator. So this particular party is not the DSO or the ESO, but it's a neutral party that is responsible for procurement of flexibility services to meet all the needs of the networks. So at this point, I think I'll just do a bit of a deep dive into how we actually developed these models. So it was a bit of a long journey. We started in 2017. So we basically went out to industry and we gave them the opportunity to highlight to us like what are some of the different options they want us to explore for the transition. So industry came back and they outlined the 5 future worlds that we've just looked at. And then we basically used a methodology called SCAM, which is Smart Grid Architecture Modeling, to basically develop these future worlds in more detail to understand what those really mean. So the SCAM methodology was developed by the Smart Grid Coordination Group as part of the European Commission mandate. So the SCAM, essentially, it's a holistic 3D framework for modeling smart grid solutions. So it basically has 5 interoperability layers, and it gives you the opportunity to model complex aspects of the electrical network, and then you can consider them from different perspectives. So we engaged EA Technology to develop the SCAM models for us. So how the models were actually built. So as I mentioned before, we basically built these models through substantial stakeholder engagement. We held industry workshops to develop each of these models, and we used our DSO functions as a starting point for each of the worlds. So through these workshops, we basically took each function at a time, identified what are the activities that sit under those functions, and what are some of the actors or the players that are involved in helping us deliver those activities, and then we mapped out what are the information exchanges that are required to deliver that particular activity within that function. And then we went a step further and tried to understand how those information exchange links are basically captured, and then in what time scales that information needs to be exchanged. And then EA Technology basically built that into what they call an actor relationship model that was then transposed into the full detailed 3D SCAM models. So the tool that was used to capture the SCAM models is called Enterprise Architect. So it is quite a complex software that allows you to capture all those links between all those different actors across all the functions, across all the worlds. So basically, the feedback that we got from our stakeholders was that Enterprise Architect is an incredibly complex tool to navigate. So what we did was we basically developed interactive web pages that would help stakeholders to actually navigate the models and understand what some of the links are. So through these interactive web pages, you can actually navigate the models either by choosing which actor you want to see or by choosing which function you want to see. So both the interactive web pages and also the full enterprise architect files are available on our website. So now just zooming out of the deep dive a little bit. So basically we completed the modeling for these 5 future worlds, and we consulted with industry on that. So in terms of our next steps, we basically now have undertaken an independent impact assessment. So we've engaged Farina partners to basically understand, like, what are the relative strengths and weaknesses and relative costs and benefits across these worlds. And so that's basically open for consultation at the moment, and consultation actually closes today. So if any of you are interested, do let me know, and we can talk about maybe getting an extension. Some of the key insights that came out of Farina partners' work was basically, so in their relative assessment across all the 5 worlds, so what they've concluded is that as standalone worlds, basically all worlds are capable of delivering net benefits by 2050, but there will be different trade-offs between the worlds. So what they have done for us is they've outlined different pathways that the transition can take. So we may start in one world, and we might be driven by a number of external factors and may have the flexibility to transition to another world. So I've got a few links in the slides as well, so I think you might find those helpful. So as I mentioned, so we have 6 work streams. So I've just talked through one of our work streams. I won't take all afternoon talking through all of our products and outputs, but this slide basically just summarizes some of the work that we've done in our other work streams. So in our flexibility services work stream, last year, basically we looked at what are some of the services that are being procured by networks. We tried to bring some commonality by defining 4 active power services and identifying what their requirements are for all the networks to use. So I think basically this would allow, from a stakeholder's perspective, this would simplify the process and bring a little bit more standardization in how services are being procured. This year we are looking at flexibility market principles. So basically these principles would apply to the DNO and also like all the other actors that are involved in the marketplace to make sure that the market can operate in a fair way and a level playing field is provided for everybody. And then in terms of our TD data exchange work stream, we have looked at investment planning. So this is one of our key areas of work as well. So last year we identified a methodology that would basically allow us to look at how we can use distribution-based solutions to resolve transmission issues. So this year we are undertaking case studies for that, and we're going to expand that methodology to a step beyond to look at whether or not we can also use third-party solutions to resolve some of those transmission issues. So in the customer information provision and connections work stream, so last year we mostly focused on identifying good practice across networks for different stages of the connections process. So this was basically to make sure that we can kind of have a more standardized approach, provide more simplicity in how stakeholders are getting connected, customers are getting connected to the grid. So those are also all available on our website. This year we're undertaking further work to look at whether or not we can have a central system-wide resource register in place that basically has all the details for all the resources that are connected to the network. So stakeholders have told us that they would find this information useful, especially if it is centrally provided. It can help them with making investment-related decisions. And then with the whole energy systems work stream, as I mentioned, we are undertaking a scoping exercise, and some of the potential areas that we could be looking at progressing this year could be cross-sector investment planning. So we can build on the investment planning that we've identified under the other work stream and see whether or not there's ways we can look at maybe solutions from other vectors. And we can also look at system operations, so we can see how for example, gas and electricity can come together and basically like deliver more coordinated processes that could be more efficient and cost effective. So this is my final slide. So just at the bottom of the slide, I've put a link to our project initiation document. So this is basically our scoping document that outlines all the work that we are planning to undertake this year. So if anyone's interested, you can visit that. Okay. Questions?
I don't know if that's included in one of the words in the United States. You know, people are talking about having a transactive system with peer-to-peer transactions and blockchain settlements. I mean, I'm not sure which of the world that would fall under
So,
your system. But the question there is always, okay, in this kind of system, how is the risk going to be distributed along the supply chain? How much risk are customers going to absorb as opposed to which now is all concentrated in the system operator? And so this is and then who is going to pay for the infrastructure? We are now on a system which is totally based on volumetric charges, and now you're talking that you're going to have prosumer and prosumage, and most of the energy is going to be produced internally by the prosumers. So who is going to be left holding the bag for the infrastructure, and how much is it going to cost to create that system with multi-directional flows, which is not what we have now?
So, couple of things on that. So yes, we are looking at that. So as part of our flexibility services work stream, we have another product that is looking at basically peer-to-peer trading or some of the more innovative flexibility solutions. So that's something that we will be looking at later on this year. In terms of, I mean, this is all kind of new territory for everybody, and we kind of are taking a learn by doing approach in this. So we are counting on industry trials to help us inform like what some of the implications of this are.
Is there a ballpark estimate of how many $1 billion is going to cost to change the distribution system to enable multi-directional flows and to enable all these bright tail and bushy eye scenarios?
So, well, I'd kind of take a different angle to that, and I'd say as part of the Open Networks project, we are basically looking at how we can operate more efficiently. So for example, with the flexibility services work stream, so that work stream is specifically looking at how we can actually avoid costly traditional solutions such as reinforcement or build solutions. So I mean, using flexibility is actually more cost effective for the end consumer. So I mean, that's...
It takes more than that to create, to allow multi-directional flows.
I mean,
I should say, specifically on the issue of volumetric charging, I think what you need to do is learn from the British and have a fixed network component.
Okay.
Anyway, what the question is?
So I understand this is a very high level, policy level model of business model.
Yes.
But is there any open data? Can we, for example, data exchange?
Yes.
Is there going to be like a portal, semantic web, some templated scenarios? And
Yes. So the system-wide resource register that I very briefly touched on, so that's basically going to be an open source of information for customers and for stakeholders. But also in the UK, BEIS have commissioned the Energy Data Task Force that is looking at how basically like data across the energy system can be made more openly available. So I mean, there are these two, so there is this deliverable that we're looking at, but also like across electricity networks as well, like traditionally like there hasn't been as much data exchange between transmission and distribution as there could possibly be. So as part of the TD data exchange workstream, we are looking at how we can basically have more real-time data exchange between networks and make sure that
what about the rest of us? Is it going to be like open data?
Yes, so to answer your question, the system-wide resource register will be open data for everybody to use.
That point actually, if I can add. So I work for National Grid, and one of the things is sign up to mention, and we've wherever. Now we're right at the start of trying to do. It's not going to be quick. I will push in your direction. Let us know where to start. I can't just open a floodgate of all data all at once. What's most valued to people out there? I would say engage with engage with us through our regulatory controls. Where to start.
Yeah, so I think my question was exactly in relation to that. But yesterday I was talking about like 10 years of research that we did at Carnegie Mellon also. We can break the system into these different stakeholders. What is the minimal information that you must exchange for what functionality? That is fundamentally a very big research question. You can't just put everything from us to use and broadcast it and so forth. So I guess what I would like to say, and it's close to my research and to our activities, but I think it's fundamental. How do you break one single service into functionalities that different entities would be doing, and what information do you need to exchange at what rate, so that you see those efficiencies with different spatial and temporal granularity? I think in context of I&I, that should be a very big research agenda. We have done a little bit on that, but you can't just ask utilities to share everything, right? So I think that's where the industry should work together on. You have to go from
Definitely, yes.
some link, but I don't have to tell you everything what's going beyond below there and
Yeah.
distribution level. So do you have any agenda on how do we define these functionalities? Are they non-unique or what's going on?
So I think the future world's modeling work that we've done through the SCAM models actually allows us to explore like what kind of data exchanges are actually needed between different actors to support different functions.
So that's a centralized model, right? This is a very different model we're talking about.
So
That stakeholders provide some things, it's a completely different model than traditional vendors models like SCAM. So you know that, right?
So can you, sorry, when you say a central model, can you,
SCAM model is not distributed model, which right, it's centralized model.
but it's kind of, a step in the way, because we need to start exploring what are the different options for us to transition, to be able to deliver this smart, flexible system in the future. So that's at least a stepping stone, and I think and this year we do have planned for further modeling as well, but, as a starting point, we need to explore all the options that are available.
I would just say it's a very researchy question, and I think that for this community it's important to appreciate that fact. How do you decompose one centralized model into a lot of functionalities, and then reintegrate it to the right information exchange? We have not studied that problem much.
I think we have one more quick question here, and then move on.
Very quick one. Can you give me any information about the members of these emails?
Yes. So I'll just quickly scroll back to one of the slides. So we've got the members here. So these are the electricity transmission and distribution members that are leading this project.
Thank you.
Right.
Does it mean that one day in election portal it will be possible to download separate generators according to fuel type with resolution 5 minutes, or it will never happen? Because right now it's all aggregated, right?
Yeah.
It will not be disclosed because it's sensitive, or if it is possible in future.
So
We can subscribe, yeah. But it's not a project.
okay.
Okay, so thank you again.
Thank you.